Okay, so we've got an interesting one on the workbench today. This is a roller door operator for a large industrial roller door, okay, which is working half the time or less than half the time in the field. You push the button, it indicates input, but it doesn't actually operate the door. Okay, if you can look at my tester now, I'm connected onto the 24 volt supply of this unit. It's got two supplies, one that goes to 5 volts for the control circuit, and the 24 volts that's used for the safeties and for the relays and all that. So I'm on the 24 volts without any load at the moment. As you can see, this tester is reading about 30 volts, okay? That's not the problem. Look what happens if I lift the board up a tiny bit or manipulate it. Now it wants to behave. There, see, I've just put a little bit of stress on the board and it's dropped down to 14 volts, which isn't enough to operate the relays and everything like that. Just by lifting the board, and I could even see that the indicators go a bit dim here, which basically means that we're losing voltage. We've probably got a short that's happening somewhere in the board that's causing our voltage to drop on the 24 volt rail. Okay, so there I am at 11 volts, right? Okay, I'm at 11 volts now, which means everywhere on the 24 volts I should have 11 volts. Okay, roundabout. Checking on the regulator, I should have 5 volts out. Yes, that's fine. But still my voltage is dropped on the 24 volt circuit. Okay, so somewhere along here, it looks like 24 volts is getting a resistance to ground, right? Okay, so what I want to do, I want to split the circuit, inject some current in here, and then I can see basically what's happening. Okay, where's my 24? 24 is here, which comes from the capacitor. From the fuse holder. Okay, 24 volts comes through the fuse up here and down here. So if I take the fuse out and I inject 24 volts and ground here, then I'm not backfeeding anything, and then we can actually see if anything's going to heat up, because maybe this power supply, this transformer, is too small to allow a decent amount of current through for my thermal camera to pick up any heat. So let me do that. Could be an internal, or no, there's only a 2-layer board. So it could just be a short somewhere with one of the vias or something. Let me crank up the voltage to 24. If I check my voltage on my tester, 14, 23. So let me just carry on manipulating this thing, try and get it to drop the voltage again. Which now it's not going to do, eh? If I can't get it to drop with the fuse out, does it mean that the problem's further back this way? So now this is without the rest of the circuit. I'm just testing the primary side here. Well, not the primary part of the circuit. There we go, 14 volts. So it looks like the problem from the transformer, these bridge rectifiers, capacitors, somewhere this side. Let me move the regulator back. I know the regulator is regulating, giving out 5 volts, so I don't think that would be a problem. I think let me try the thermal camera on this section alone. So it might not be a short, it might be just a poor contact. Maybe I have to reflow on the transformer. That would be interesting. Because I was sure as the board was flexing it was short. And I was thinking it would have been somewhere in this area. I didn't really think it could be the supply side. Okay, thermal camera. Okay, that's the volts regulator. That's so hot there. Which is possibly also messing up the other readings. Shield. I'm not seeing any heat. Okay. Maybe the transformer just needs to be reflowed. Pads. Okay, so let's. The first one, yeah. Second one. That one doesn't look too good. If I'm looking at it, it's kind of a dull. I think, yeah, let me reflow it. I wonder if I should take the existing solder off. Put up. Might as well. Well, let me resolder these first. I'm also going to redo this primary side. This board is quite an old one, so it could just be poor connection. The transformer hanging around for a while. I want to put my tester back on the pins so I can flex the board a bit. Okay, so 30. No. And I know it's not a short. I don't see any damage to the traces. Anything that looks like corrosion. Okay, so what I'm doing now is I'm just reflowing the bridge rectifiers. not very cleanly, I must say. Okay. Plug it back in. Tatty. We're staying up at 30s. I've seen no change at all now. So, poor connection on the bridge rectifier. It's interesting. Okay, well I'm just going to, off camera, I'm just going to reflow these bridge rectifiers, replace the missing LED from up here, and then, yeah, I'll test it again. 30 volts. Okay, I've reflowed those bridge rectifiers nicely. I only had an 805 surface mount LED, so I'll put an 0805 in there, but that is working. And no matter how much I flex this board, I don't want to flex it too much, but I mean, that's not going down. So I think that part is fine. Okay, so I guess the only thing next to do next is go and install it. I've got the controls connected up to it now. I've also bridged out the high and low limit switches and the safety beam and all that. So let's see what happens. Got light, that means our safety switches are on the small little wicket gate are bridged out, which I've done over here. So if I push this, we've got one relay that clicks, okay? So as I'm doing that, pushing the button, the up and down relays are clicking like they're supposed to, which is something it wasn't doing in the field. Let me take a bit closer. Okay, so if I push the button, you should see one, and then when I push it, it'll stop, and then I'll push, and then the other one should go on. That's the different directions that it supplies phases to the motor. So let's see. Top one flagged on, top one flagged off, bottom one flagged on, bottom one flagged off, and that's basically it. If you do, it has got a timer setting here, so that if it does run more than a certain amount of time, it will shut off. That's just an extra precaution if your safety switches don't work too well. But I think this thing is ready to go and install. Okay, so here's the board back in its natural habitat. As you can see, the e-stop is out, but we don't have a red light. That's because of the safety switches. There's a safety switch over there and one down there. It'll only let this door accept inputs and that when that little wicket gate is open. So that's why we don't have a red light yet, because it means we don't have any way to open the door. Okay, then here I am at the top of the door. Let's try so you can see up this door here. Okay, I have sorted out connections to those wicket gate switches. Okay, if I had activated the door now, this would have been bad with the manual override handle thing here, manual bypass. So it would have spun and blown out and hit somebody on the head. So let's take that out. Hang it back up on the conduit. Most good place to keep your handles on the conduit. And if you look over here, there's two limit switches. This is the normal one that tells us the door's at the top, it mustn't go up anymore. If it does overrun this limit switch, then it's got this limit switch that actually on the board there's an input that disconnects the neutral. So you kill the whole control board, drop out the relays, and the motor will stop spinning. So that's just a last ditch safety. We are going to be installing one on the bottom end as well. At the moment we've just got a normal limit switch on the bottom end. Now I need to unlock the door and then we can test it. Okay, so I'm opening the wicket gate here, which you can activate that limit switch and that limit switch, and then after that we should have a red light. Just chain it up. Okay, so now we should have a red light. on the manual motor starter here. And then we've got a red light. So now, push it, button, and it's going up. It'll go up until it hits that top limit switch. It shouldn't hit the second limit switch. Okay, so there we go. We are all the way up. And if we look over here, the open light is on to say the door is open and it's not closed. Okay, so now let's try that again. Going down. And it should run until it hits the bottom limit. Down. Okay, and then if you look here, it's not open, it's closed. So that's basically it. Now I just have to close up this box and then we're good. So finally we're back to a bit of electronics where we have sorted out this control board. Basically it was missing an LED, but that wasn't too important. It had poor connections on these bridge rectifiers. So yeah, now that we've sorted that out and I've sorted out the corroded wire, we're good to go. So thank you. If you like this video, share it, give it a thumbs up, do whatever you want to do. Thanks.